Intermediate Algebra for Statistics, Modeling with Quadratic Functions, Part 2. Lesson Objective: use a quadratic model to make estimates and predictions. Example 2. The number of video cassettes and DVDs bought by U.S. dealers to sell as rentals are shown in the table for various years. In the late 90s, there were a large number of video cassettes. This is measured in the millions, but as time goes on it decreases, and in the late 90s the number of DVDs were very low, but they start to increase at a faster and faster rate. Estimate when the sales of DVDs to dealers overtook the sales of video cassettes to dealers. Solution: the scattergram for the video cassette is here. So we saw the trend in the table increasing up to a point and then decreasing. For the DVD, it started out very low, but then once DVD started to catch on to increase at a faster and faster rate. So the quadratic model that models this data is negative 6.27 t squared plus 129.7 t minus 576.2. The model for the DVD is 4.83 t squared minus 79.1 t plus 326. So we see A in this case for the video cassettes is negative, so the parabola is going downward. A in this case for the DVDs is positive, so it's going upward. So there is a maximum for the video cassettes and there is a minimum for the DVD. Graphing the model with the data, we see that this is doing a very good job of modeling the data pattern, and so is the one for the DVD. Next, to find when they're equal, we set the two functions equal to each other. The next step is to move all the terms to one side so it's equal to 0. So we have negative 11.1 t squared plus 208.8 t minus 902.2, and that equals 0. So this is our value of A, this is our value of B, this is our value of C. Substituting these values in our quadratic formula, we have negative B plus or minus the square root of B squared minus 4 times A times C, all divided by 2 times A. We get T is approximately equal to 12.09, or T is approximately equal to 6.73. So please take the time to verify this. So this value corresponds to about 12 years beyond 1990, and this value corresponds to about 7 years beyond 1990. So here we have in the year 2002, and this will be the year 1997. Now, since we are interested in finding the value where the DVDs overtook, we don't need this solution. We only need this one. So we would say, according to the model, in about a little more than 12 years after 1990 and 2002, the DVDs outsold the video cassettes. To verify this using a graphing calculator, our point of intersection is about 12.9 and the Y was about 75.5. So we would say at this point in about the year 2012 these two were equal, and that would be about 75.5 million. Beyond 12 years, the DVDs will outsell the video cassettes. Example 3. The average per minute cost of cell phones have declined greatly since 1998. So in 1998, the average per minute cost was 34 cents, and each year the cost has decreased. Let C equal f of t be the average per minute cost, measured in cents, of a cell phone at t years since 1995. A. Find a linear regression equation and a quadratic regression equation of f. Compare how well the model fits the data. B. First use the linear model and then the quadratic model to estimate the average per minute cost of cell phones in 2001. Which is the better estimate? Explain. C. In 1995, the average cost of a cell phone was 64 cents per minute. Find the c-intercepts, first of the linear model and then of the quadratic model. Which intercept describes the situation better? Explain. And D. For the periods 2004 to 2006, which model would cell phone subscribers hope would describe the situation better? Explain. Solution. Part A. We put the data in list 1 and list 2. And here's the scatter plot. For the linear model, we have y equals negative 3.71 plus 42.29. The r-square value is 0.947. So it looks like the line is doing a pretty good job of modeling the data pattern. So the linear model will be f of t equals negative 3.71 t plus 42.29. Let's do the quadratic. We see that A is 0.5, B is a negative 9.71, and C is 58.29. Our r-square is 0.998. This is very high, so this is likely the best model. If we graph it with the data set, we see this is doing a very, very good job of modeling the data. So for the quadratic model, we would say f of t equals 0.5 t squared minus 9.71 t plus 58.29. B, for the year 2001, that means t is equal to 6. Plugging 6 into our linear model, we have an output of 20.03, and for the quadratic, we have an output of 18.03. Using a graphing calculator to verify, I put the linear model in y1, put the quadratic in y2. Using the var key, 6 evaluated for y1 has an output of 20.03, and 6 evaluated in y2, the quadratic, gives me 18.03. Part C. For the linear, the c-intercept, we let t be 0 and we solve for c, and we see that the intercept is 42.29, the same value of b, the y-intercept. For the quadratic, do the same thing, substitute 0 in for t, and we see that the y-intercept is 58.29, and this is the value of c. So which one's better? The c-intercept indicates the cost in the year 1995. The quadratic model yields an estimate that is closer to the actual value of 64, so it appears to be a better fit. Using the graphing calculator, with y1 being the linear model and y2 being the quadratic, we can do y1 of 0 and we get the value of 42.29 b. So to get the y-intercept for y1, we put an input of 0, we get an output of 42.29, and for y2, put an input of 0, we get an output of 58.29. So we have verified the c-intercepts. D, we want to look at when t is 9, 10, and 11. y1, the values are going down, and y2, the values are starting to increase. So we would say for the years 2004 to 2006, and that's when t is 9 through 11, the cell phone subscribers would prefer the linear model since it indicates the price per minute will continue to decrease, whereas the quadratic model would indicate the price per minute begins to increase after 2004. Thanks for watching.